Hi, my name is Morgan, and this is my presentation for our data mining and data analysis final project. So I wanted to look at information along the lines of the industry that I'm in, which is recruiting, and around optimizing processes so that we'd be able to really narrow the focus on where we put our energy in recruiting. Or even in business development. So the two data sets I selected were the state of Colorado, which was the long-term employment projections over 10 years by industry and occupation by geographic area. And then the other was the U.S. Bureau of Economic Analysis, which was wages and salaries by industry quarterly from 2021 until Q2 of this year. Just based off of the two data sets that I was looking at, I was looking to answer the question, is there a correlation or significance between the projection of jobs by industry and the total salary by industry? And then software and statistical method I wanted to use was, I really started off with Python and then moved to SES, looking at the k-means clustering to see if there was that correlation between the two. So next, data munging or cleaning, really looking at your data, getting, understanding it, maybe running descriptive statistics on it, and then just looking in general to see where there might be duplicates and or no data. So I needed to rename columns so that I could naturally join the data sets through a common column name. And based off of the indexes and key value paired, it was going to be off of industry. So on the Colorado data set, I changed one of the columns to description so that I could join them. And then I removed columns that had no data at all. I didn't really find any that were irrelevant. I know some of it was repetitive, but not really irrelevant. I went ahead and left some of it with zeros, especially I thought it was significant when there was 0 jobs being added in some of the columns, so I did leave those. So initially I did it through Python, and I imported the packages that I needed to do it with, which you can see at the top, and then imported the CSV data, exploratory data analysis, looking at how many columns through the shape function, and then descriptive statistics, how many null or no values, and then duplicates, all helping to determine, that initial cleaning stage. And then natural join, I did through a merge, matching it again, renamed the columns to the to description, which you can see on there as well. And then the visualization and statistical analysis function I struggled with, which is when I then switched over to SAS. So here are the two data sets initially that I downloaded as CSVs from the websites. And as you can see, you have description on the bottom that gives you examples of the industries like mining. And then at the top, you see main title that gives you accommodation and food services. Those were the key value pairs that I found matches in. And then I changed the column title to, or header to description on the main title to match, to naturally join the two data sets together. I could have also went through and narrowed down the names to match more. There was a lot less industries within the bottom data set from the U.S. Census Bureau versus the top data set. But for this, I decided to keep it separate just so I could kind of look at it personally at separately, more defined from the top data set to really see what the demand was within the different industries. So now we have the two joined data sets within the SAS platform, and what I found here is that it's much easier to manipulate the data in order to make different clustering and different analysis within this software platform. So here you see in the joined platforms, you see the industry off to the left highlighted blue. You will see the specific job titles are kind of rainbow due to me manipulating the data already. And then what's convenient now is that it is linked so that you can see the total industry GDP by quarter off to the right-hand side. Now, there are blank areas, which I could have expanded the industries a little bit since they are similar, but it was just the same numbers over and over. And I felt as if I could, it wasn't going to change the analysis of the project since the numbers weren't going to change. It's just predominantly going to be the exact same numbers spread across different titles. So here's really where I began my analysis and, just kind of playing around with the platform. So the cluster comparison report, it allows you, I put up to 15 clusters. So what it does is it gives a fit statistic to compare the various models to then output the best indicator of a fit, which in this example, you can see that noted by the CCC, and it was five clusters. So this report then gives you the mean, the standard deviation, and a summary report, essentially meaning that it gives you the number of clusters and the observations in each cluster, as well as the number of iterations required in the overview. And then in the means report, you get the means for the observations in each cluster for each variable. And then the cluster standard deviation report gives you standard deviation for the observation in each cluster for each variable. And you can see those reports below. And then next you'll see some of the visualization from those reports. So the top one is the parallel coordinate plots display, and it displays the structures of the observation in each cluster using plots to see how the clusters differ. This shows a plot of the points and clusters in the first two principal components of the data, along with the legend identifying the cluster colors. Circles are drawn around the cluster centers, and the size of the circles is proportional to the count inside the cluster. You can see that on the next graph with the 1, 2, 3, 4, 5, with most of the cluster being within that 5 circle. The shaded area is the density contour around the mean. I did remove that from mine because it was just shading the entire box based off of, most likely because they were all within the same industry. By default, this area indicates there's a 90% of the observations in that cluster would assigns colors to that identity. So if there's a biplot in the report window, the colors saved to the data table match the colors of the clusters in that biplot. So that's what you're seeing off to the left. I was able to save the colors so that it divided them out, which you'll see a little bit later, my second analysis that I did a little bit more detailed where you'll really see those colors come up in the analysis. And then the saves K column containing the squared Euclidean distances to each cluster center. You'll see that at the beginning reports I showed you, since I had already done some analysis and saved the distances in there. You'll see that at the end. It just attaches it to your data set for each of those variables. So here is just an example of where I took 2 software developers for applications and looked at 2 different points or rows within the data sets. And, interesting, there's the highest growth rate is at 19% and 177% change rate. And then which was again for the Aurora area. And then for combined industry, it's 16.8 million GDP. So really the highest demand and highest GDP is what I selected for these 2. And you can see they're really right in the middle of that number 2 cluster. And then the outlier ones in this bottom right, those really, which will show up again later, those are like the combined totals that probably could have been part of the data cleaning process and removing them, since they're not exactly relevant to this, what we're trying to look at here, since it's a combination of the entire industry, computer industry, and another by state. So here you can see where I really broke down this even further by industry, and this time I believe I just did Q1 and 2 of 2022, but really focused in on specific roles by industry, and did the 3D by plot here as well, with the same outlier showing up, which is being all computer industry and then the entire state industry. And what that means is instead of needing 25 or seeing a growth of 25 software developers over 10 years, you would see 25,000 software developers, since it was an industry-wide or it was a statewide, versus just like a construction need for software developers. While I didn't necessarily see the correlation or significance between necessarily the GDP and demand for jobs, just because it was so broad, and I would need to narrow that down further with a different data set, more specified. What I did find most interesting with these two data sets was something that I would not have anticipated was the construction industry being one of the highest in demand for software developers for applications, as well as having the highest GDP. And that beat out the information industry, meaning that a lot of your computer companies or software as a service type of companies didn't have as big of a demand as what the construction industry does for the state of Chicago. Something else I thought was interesting is computer hardware manufacturing had some of the lowest, if not negative, projection of certain industries, and then just overall looking at the demand of different jobs like software developers, information security being in such high demand, as well as anything to do with computer and mathematical occupations, specifically along the lines of data scientists and data analysts are very high in demand across all industries, which is what the cluster and k-means really showed. It's just in general the consistent demand and very close similarity across all industries and the need for these jobs.